Long before Earth existed. Long before the sun ignited. The universe was a place of darkness slowly giving way to light. Tiny fluctuations left behind by the Big Bang gradually pulled matter together. Clouds of hydrogen drifted through space, collapsing under gravity until the first stars burst into existence. For decades, astronomers believed this transformation happened slowly, over hundreds of millions of years, as the earliest galaxies cautiously assembled themselves. That picture is now being rewritten. Nearly 1.5 million kilometers from Earth, the James Webb Space Telescope quietly observes the oldest light in the universe. Shielded from the sun by its enormous 5-layer sunshield, Webb operates in the cold vacuum of space, collecting faint infrared light that has traveled for more than 13 billion years. Every image it captures is a glimpse into the distant past. Every spectrum is a record of cosmic history. Instead of simply confirming what scientists already expected, Webb has uncovered a universe that appears far more active during its earliest moments than anyone imagined. One remarkable example comes from galaxies that formed only a few 100 million years after the Big Bang. According to earlier computer simulations, these young galaxies should have been relatively small, chaotic collections of gas and newly formed stars. Heavy elements should have been rare because there had been little time for stars to live, explode, and enrich their surroundings. But Webb saw something different. Several distant galaxies appeared unexpectedly bright and chemically mature. Their light carried evidence that earlier generations of stars had already lived and died, releasing elements such as oxygen into surrounding clouds of gas. This discovery surprised astronomers because oxygen cannot exist without stars first creating it. Inside every massive star, nuclear fusion gradually transforms lighter elements into heavier ones. When those stars eventually explode as supernovae, they scatter those newly created elements across space, providing the raw materials for future stars, planets, and eventually life itself. Finding oxygen in galaxies so early in cosmic history suggests that this entire cycle unfolded much faster than researchers once believed. Rather than slowly evolving over billions of years, some regions of the young universe may have experienced extraordinary bursts of star formation almost immediately after the first galaxies appeared. Massive stars ignited. They burned through their fuel at incredible speed. Then exploded in spectacular supernovae. The debris from those explosions became the building blocks of the next generation of stars. Each cycle enriched the universe with increasingly complex chemistry. What once seemed like a gradual process may, in some places, have unfolded with astonishing efficiency. Yet galaxies are only one piece of the puzzle. Webb has also begun exploring objects much closer to our own cosmic neighborhood. Among them are mysterious bodies known as brown dwarfs. Often called failed stars, brown dwarfs occupy the boundary between planets and true stars. They possess more mass than giant planets like Jupiter but never become hot enough to sustain the nuclear fusion that powers ordinary stars. For many years, astronomers assumed these objects were relatively quiet. Webb revealed something far more fascinating. Its sensitive infrared instruments detected complex atmospheres filled with water vapor, methane, and swirling clouds composed of exotic materials unlike anything found on Earth. Some brown dwarfs even showed changing patterns of brightness, suggesting enormous storms moving across their atmospheres. Powerful winds may circle these worlds at tremendous speeds. Towering cloud systems could constantly reshape their skies. In some cases, astronomers have even observed evidence of intense magnetic activity producing brilliant aurora-like displays. These discoveries reveal that even objects once considered simple can possess surprisingly dynamic environments. Every new observation reminds scientists of the same lesson. The universe rarely behaves in the simplest way possible. Instead, nature often proves richer, more complicated, and more beautiful than our first theories suggest. As Webb continues collecting ancient light from across the cosmos, one thing becomes increasingly clear. Humanity is not merely filling in the missing pages of the universe's story. We are discovering entirely new chapters that no one expected to find. The deeper astronomers explore the universe with the James Webb Space Telescope, the more one truth becomes impossible to ignore. Space is not a quiet, unchanging void. It is a place of constant motion, where gravity reshapes entire planetary systems, stars are born from collapsing clouds of gas, and worlds can disappear as easily as they form. Every new observation reveals another chapter in a story that has been unfolding for nearly 13.8 billion years. One of Webb's most fascinating discoveries involves distant exoplanets, worlds orbiting stars far beyond our solar system. Until recently, astronomers believed many planetary systems would resemble our own, with planets traveling along relatively stable, circular paths around their stars. Instead, Webb has revealed remarkable diversity. Some giant planets follow highly elongated orbits, carrying them extremely close to their stars before sending them far back into deep space. Others appear tilted at unusual angles, suggesting that violent gravitational encounters occurred billions of years ago. Scientists believe these strange orbits may be the result of interactions with neighboring planets or even passing stars during the earliest stages of a system's formation. These ancient gravitational encounters left permanent marks that can still be observed today. Every unusual orbit tells the story of a turbulent past. Some planetary systems experienced stability. Others survived cosmic chaos. Another extraordinary class of worlds has captured astronomers' attention. These are giant planets orbiting so close to their parent stars that they complete an entire year in only a few Earth days. The intense heat from their stars causes temperatures to rise to thousands of degrees. Powerful radiation strips away their outer atmospheres, allowing streams of gas to escape into space. Over millions or even billions of years, some of these planets may lose a significant portion of their mass. Although these processes occur slowly on human timescales, they demonstrate that planets are not permanent objects. They evolve. They change. And sometimes, they slowly disappear. Meanwhile, Webb has also turned its attention toward enormous disks of gas, dust, and ice surrounding young stars. These swirling structures are known as protoplanetary disks, the birthplaces of future planets. Inside these disks, microscopic grains of dust repeatedly collide and stick together. Over countless collisions, they grow into pebbles. Pebbles become rocks. Rocks combine into mountain-sized bodies. Eventually, gravity takes over, assembling entire planets. It is a process that transformed our own solar system more than 4.5 billion years ago. Today, Webb allows scientists to witness similar events occurring around distant stars. Some disks already show remarkable gaps and rings. These features suggest that newly forming planets are carving paths through the surrounding material as they orbit their stars. Rather than imagining how planetary systems form, astronomers can now observe many stages of the process directly. Every observation helps answer one of humanity's oldest questions. How did worlds like our own come into existence? At the same time, Webb continues examining the chemical ingredients scattered throughout the universe. Using its powerful spectrographs, the telescope can identify molecules by studying how they absorb and emit infrared light. This technique has revealed water vapor, carbon dioxide, methane, carbon monoxide, and many other compounds in distant environments. Each discovery helps scientists understand how chemistry evolves across space and how the building blocks necessary for planets, and potentially life, become distributed throughout the galaxy. These observations do not prove life exists elsewhere. But they show that many of life's essential ingredients are widespread across the cosmos. That alone is an extraordinary discovery. Perhaps Webb's greatest achievement is not any single photograph. It is the enormous collection of evidence it continues gathering every day. Each image sharpens our understanding. Each spectrum improves our models. Each observation reveals another piece of a puzzle that humanity has been assembling for centuries. The universe is proving to be more dynamic than we once imagined. Galaxies grew rapidly. Stars enriched space with heavy elements earlier than expected. Planetary systems formed in astonishingly diverse ways. And distant worlds continue to surprise astronomers with environments unlike anything found in our own solar system. Yet every answer creates new questions. How quickly did the first galaxies truly evolve? What determines whether a planetary system remains stable or becomes chaotic? How common are Earth-like worlds throughout the Milky Way? Could future telescopes detect unmistakable signs of biology on a distant planet? For now, those questions remain unanswered. But humanity has entered a remarkable era. For the first time in history, we possess instruments capable of studying the earliest galaxies, analyzing the atmospheres of distant worlds, and watching planetary systems evolve across the galaxy.